The focus of this video is the syntax of structures and unions in C. So we're going to be looking at some tips that will allow us to remember the syntax of structs and unions in C. So first, let's start off with structures. Structs in C allow us to create complex data types, and they're essentially just a collection of variables of different data types. So they could be of the same type or they could be of different data types. So this is structures in C in a nutshell. Let's focus on the syntax here. A lot of people tend to forget the syntax and have to review the syntax before they start using struct. So this is a neat way of remembering how to write the syntax of structs. So first of all, there are two things in structs. You have to define a struct type, and then you have to declare variables of this new struct type that you've defined. So in terms of defining a struct type, here are 3 steps to remember how to do it. First of all, what is a struct? We said it's a collection of variables, so a collection of data items. So first of all, you're going to need a number of data declarations. So 1, 2, 3 data declarations of your choice, the variables that you want to put together. And then in C, the proper way of grouping things, the way we usually group things is by using braces. So you're just going to put braces around it. Then what you're going to write is the struct keyword right before it, right in front of that grouping of variables. And this essentially will define your struct type. So it's very simple. Remember, you've got your data items, your data declarations that you want to group together, and then you will use, in C we use braces to actually put them together, and then since it's a struct, you're actually just going to put the struct keyword before that. So this is the basic definition of a struct type. Then we will want to declare variables of this new struct type that we've just defined. So the way to do this, there are multiple ways of doing it. First, what you could do is you could actually start adding variable names right after the definition of the struct type. So you could start adding variable names right here and declare variables of this new struct type that you would have defined right here. So you could add hello variable, and this will be of type this struct. So this is one way of doing it, and you can put commas one after the other. Another way of doing it is by adding an optional tag right here. So you could name your struct so that you could use it later on. Instead of redefining it every time, you would just add a name to your struct right here. So call it X, for example. So your struct is called X. Then later on, what you're going to do, if you want to declare a variable of this struct type, you're going to do struct X, and then the identifier or the name of your variable of type struct X. So instead of retyping the entire definition of struct X, you just do struct X and then write the variable name. So these are 2 ways of doing it. And so this is the general form of the struct. You have the struct keyword right here. You have an optional tag. And the purpose of that tag is so that we could later on declare variables of this struct type. And then you could also have some variable declarations or definitions right after the struct. So you will define your struct type right here, and then you could have some optional variable definitions, or you could also do it this way by using the struct and your optional tag that you would have created here. You would use struct, that tag, and then declare variables that way later on. So this is the general form of the struct type, the struct syntax. Now, you notice how we have this struct that we carry around everywhere we go. What we could do is we could use a typedef to rename this struct type that we would have just defined to something simpler, to one word, for example. So we could use a typedef, and typedefs are used to create aliases for certain types. So what we're going to do is, after we define our new struct type, we'll rename it using a typedef. So you could do that in one single statement as shown here, or you could first of all create your struct. So You will have your struct right here. You could give it an optional tag, then put all the data declarations inside of it. And so then we could start declaring variables of this new struct type with the tag. So we would have struct tag and then your variable. Instead of doing that and always having to type struct, what you're going to do is you will type def struct tag to some other word. So call it tag type, for example. So now what you can do is tag type will stand for struct tag. So you could simply say tag type and then use a variable right here and declare your variable, and this tag type will stand for your struct tag. So instead of declaring variables this way using struct and then the tag and then the name of your variable, what you can now do is just use tag type and then directly the names of your variables. So this is using a typedef, and then now that we've seen how to do it this way by first defining your struct type and then typedefing it, what you can do is combine these two steps together and typedef your struct to a new struct type. So essentially, every time you will use new struct type in this case, and you could put whatever name you want here, it will be as if you're referring to this new struct type that you defined here. So in this case, all we need to do to declare variables of this new struct type is just say new struct type, which is an identifier we had put right here to stand for our new struct type, and then start putting the names of our variables. Now let's look at unions. Now, unions are very similar to structs. So they're also a collection of variables of different data types, just like a struct. The crucial difference between structs and unions is that unions only store one field at a time, or only one of their variables is stored at a time. So all of their variables are stored at the same memory offset. So they all occupy the same region in memory. So the total memory usage of a struct will be the sum total of the memory usage of all of its fields, right? So you need to be able to store all of the members of a struct in memory. However, for a union, you're going to have multiple members, but only one will be stored at a time. So we will only have space to accommodate the largest data type in that union, so that we could basically accommodate any of the smaller ones and the largest one, and then we will only store the information for one of them. So when you store information for any of the variables, it will basically overwrite whatever was in memory before that. So everything, all of the data types are stored at offset 0. They will all be stored starting from 0, whereas in the struct, we will have a large area of memory dedicated to all the members, and each member will be stored at different offsets. This member will be stored at offset 0. This member, for example, is stored at offset 12, which is basically after the first member, and so on and so forth. Whereas in the union type, every time you store something, any member to the union, it will overwrite whatever was there before. So why do we use unions very quickly? Sometimes to save space. If some of the members are mutually exclusive, so they won't occur at the same time, it doesn't make sense to have them at the same time. For example, in this case, we have a struct of conditions where we have temperature and either a wind chill or a heat index. A wind chill is applicable in the winter, a heat index is relevant in the summer. So only one of them will be useful to us. So what we do is we store them both in a union, and that means we will only allocate enough space to accommodate one float rather than two. If we had actually put these two floats as two members, then we would have allocated space for two. Every time you would have defined a struct of type conditions, then essentially you would have allocated space for two floats. But since now this is used as a union, we only have space for one float, and depending on the member we're actually storing, it will just overwrite that same region in memory. So basically this is to save space. Other usage of unions is to access individual bytes or bits of larger types. So this is used in hardware programming. So in this example, you can see that this integer and this struct, both of which actually have 32 bits, they occupy the same region in memory. So whether you store an integer whole, say you put 10 for example, then you will have the value 10 in bits here at 32 bits. Or you could actually start modifying the bytes, each 8 bits of these 32 bits. So we have 4 8 bits. So you're basically allowing yourself to access the individual bytes inside your integer right here. So these are being stored in overlapping regions of memory, and since now we could actually access each character of this integer, each byte of this integer. So this is useful in hardware programming where we want to have access to individual bits and bytes in memory. And finally, it could also be used simply as a variable format record, so almost like polymorphism in object-oriented programming, where you would have a structure that would have two members. One is a type that would tell you what is actually being stored. We will either store, in this case, an array of integers, an array of floats, or a double. And this will be given to us by the type. So you can check the type and then determine whether we have integers stored in that area in memory, which is overlapping. It's just one area, enough to accommodate either a double or an array, or just two floats basically in this case, or two integers. So what you would do is when someone would store something in that area of memory, so suppose they stored two integers, and they want the next person to come who will actually read that data to know that there are two integers here so that they don't interpret it as a double, for example, and get invalid information, then what they would do is they would they would indicate it in this type variable right here, which we've defined as an enum. So we would put ints in that variable, so the next person to come and read that value and process it however they want, they will first read this value and say, okay, I know there are integers in here, so I'm going to start processing this information as integers, and they would read this from the union rather than a double or floats. So this is used as a variable format record. So now to what we actually wanted to talk about, the syntax, and this is very quick because the syntax of union is very similar to that of struct. In fact, the only difference is just the union keyword. So if you looked at what we had before and you look at what we have here, we also have an optional tag, the identifiers, and then the variable definitions that you could either put here or declare them separately later on using your tag.